Hello and welcome to another lecture of the course Aquaculture. Within the major topic of induced breeding, today we are going to talk about inducing agents other than pituitary gland and also about significance of induced breeding. If you can recall my previous lecture, we talked about the use of pituitary glands for induced breeding. And pituitary glands are to be extracted from some fishes which are showing, which are entering into the mature phase. For that, you need to kill a prospective brooder fish which could have participated in the breeding program. And you need to have expertise in collecting the pituitary gland. You need to keep the pituitary gland, either you use pituitary gland fresh or you have to do efforts in order to preserve and its potency for later use. So, in all circumstances, when you are using pituitary gland for induced breeding of fish, then you are going to kill a large number of mature fish which could have been taken for fish breeding, and you also have to make efforts regarding its fresh use or preservation. Then you need a little bit expertise in extracting the pituitary gland as well as preparation of pituitary extract in saline. Then you have to go through the processes like homogenization. You have to homogenize that pituitary gland, the required weight of pituitary gland or dose of pituitary gland which is to be used for that candidate fish species. And after homogenization is complete, then you will have to go for the process of centrifugation, which will distinguish the debris from the supernatant, and that supernatant you have to use. Not only this, there is one more complicated process here while using pituitary gland for induced breeding, that here you have to give your dose, a split dose, one first preliminary dose and then resolving dose to the female. So, 2 doses are to be given to the female. You will have to make efforts for preparation of the supernatant that is to be injected, and you will have to put fish into stress twice in the process, female fish, and then male fish we used to give only 1 dose at the time of second dose to the female. So, by seeing all these limitations, it is quite evident that people shall be looking for more easier method. So, what happened? There are many other inducing agents. In fact, what we do in induced breeding, we simply try to simulate the conditions in which the fish can respond to factors which can influence the gonadal maturation and spawning. For spawning, there should be the release of gonadotropins which are influencing the gamete to release, and to get it at the desired time, we often take the help of inducing agents. So, if you induce the fish for breeding in a confined environment, in a controlled environment, then we call it as induced breeding, or simply whether you are inducing it in natural environment also, but you are inducing it for breeding, then you can call it. So, here in place of pituitary gland, we can use other hormones. What are those other inducing agents that we can use for induced breeding purpose? Here we are going to discuss those. So, there are many other options which are available to be used for induced breeding of fishes. For example, human chorionic gonadotropin HCG has also given good results for breeding the fish, for induced breeding the fish. Then we also have many GnRH analogs being provided by many companies with different trade names. So gonadotropin releasing hormones, we know that they play very important role in the reproductive physiology, and especially during the breeding season, gonadal maturation as well as breeding season. So you can use GnRH, but nowadays GnRH analogs are available, so you don't have to kill the fish. Are frequently used in combination with dopamine antagonist. I can tell you in one of the slides later, I have shown you one diagram regarding how GnRH acts. So these dopamine antagonists are required because dopamine, if you remember little bit of the physiology, that environmental cues impact the hypothalamus for releasing GnRH. Then GnRH activates pituitary gland to release gonadotropins. Those gonadotropins, they act on gonads for the release of gametes. That's how the process takes place. First, we can discuss one by one about the inducing agents. First, HCG, the human chorionic gonadotropin. This was discovered in the blood and urine of pregnant women in 1927 by these researchers. And what are its advantages? What it can do? It is very cost effective. When we are studying the utility of HCG with regard to fish induced breeding. So in comparison to other inducing agents, this is economical. HCG is economical. It can be stored for a longer period of time. It has long shelf life, and it is available in pure form. So regarding availability and use, you can be assured that, and this inducing agent is quite good. HCG has been used to successfully induce spawning in many species. In fact, if you will go through the literature, then there are many fishes which have been induced bred using human chorionic gonadotropin. The catfishes example we discussed in the previous slide. And now Labiorhita has also been reported to respond to HCG injection and breed. The doses may vary in different species. It's not that is, whenever we talk of doses of any inducing agent, any hormonal injection, then be very sure that whatever is written, that is only a reference. What you have to, what dose you have to select, that depends a lot on the condition of physiological condition or stage of maturation shown by the fish you have selected for breeding, and the climatic conditions at that particular day. So depending on all this, if your fish is in running stage, showing release of gametes by a very gentle press of the belly, then you can go for lower doses of any of the inducing agent. And if the fish is not showing very good signs of running stage, but it is mature, showing maturity, but not in the running stage, then you may have to go for slightly higher range of the dose, whichever inducing agent I am talking. And if the conditions on that particular day are not suitable, the environmental conditions, the climatic conditions on that day are not suitable, not simulating the kind of environment that this fish needs for breeding, that this fish will take as cues from the environment. So again, you will have to go for little higher dosage. So that is why you may see, if I have given you here very few references, but you can go through many references where you will find different doses, and sometimes a fish may respond, say for example at 600, but sometimes you have to use higher than this, maybe 1000, and the fish will not respond. So, it all depends on many factors, especially the condition of the brooder. Cyanohorin is another example inducing agent that has been used. What is cyanohorin? Cyanohorin is a mixture of chorionic gonadotropin and mammalian pituitary extract, and this is prepared, synthetically also. Cyanohorin is has mainly been used in Japan and Taiwan for producing fish seeds, and they have got very good encouraging results with cyanohorin. And cyanohorin in all the fishes may not produce the same result as in any other species. For the earlier one, HCG, also I told you that sometimes it is used in combination with pituitary gland. Here also cyanohorin was not successful in inducing spawning in Labiorota. But when cyanohorin was combined with pituitary gland, here 25 ml cyanohorin, of course per kg body weight of the fish, it is referenced, 4 mg of PG, pituitary gland per kg of body weight. If this combination was used, then Labiorota responded positively and it induced spread. So, that is one of the products, cyanohorin. Now, this is the product which has, in fact, I should say, revolutionized the induced breeding or fish seed production in many parts of the world. In our country also, Ovaprim is being used for a very long time. In fact, Ovaprim we have got from Sindel Laboratories, Canada. And what is the composition of Ovaprim? Salmon GnRH, salmon gonadotropin releasing hormone from salmon, and a dopamine antagonist, here in this case domperidone. Nowadays, they are using sGnRH analog. sGnRH analog they are using. What is the rate? 20 microgram per ml, and domperidone, which is a dopamine antagonist, at the rate of 10 milligram per liter per ml. So, that is the active ingredients concentration in the vial that you will get. And what is the function of these two, that we can discuss a little later. Ovaprim is the first legally marketed US FDA injection with ornamental fish broodstock. In fact, this Ovaprim inducing agent is being used for fish breeding in different parts of the world for a different variety of species, and even for ornamental fishes. And Ovaprim has given, for a range of species, it has given excellent results as far as induced breeding is concerned. All the parameters of reproductive performance, if you will assess while using Ovaprim, it gives one of the best results. sGnRH analog in Ovaprim, what sGnRH analog does, the salmon gonadotropin releasing hormone analog, it helps to release the gonadotropins from the pituitary. It acts on the pituitary GnRH and stimulates pituitary to release gonadotropins. GnRH is the key mediator in liberation of the pituitary gonadotropins. We all know LH and FSH. The dopamine, then what dopamine inhibitor does? Dopamine antagonist, that is domperidone. It serves to remove inhibitions of GnRH release. In fact, dopamine inhibits the GnRH release from the hypothalamus. So, what domperidone does? It is an antagonist of dopamine. So, it removes the inhibition of dopamine for GnRH release. So, you are giving GnRH and you are also using dopamine antagonist. So, the GnRH effectiveness will increase and the fishes will respond by releasing the gonadotropins. Here it can be understood, you must have gone through such kind of flowcharts or diagrams. through the environmental cues in natural environment, what happens that through the environmental cues, the hypothalamus gets stimulated to release gonadotropin releasing hormone. Environmental cues means when in the conditions in which the fishes respond to the environmental factors for responding. So, if the fishes have matured, as soon as they come into, I told you about these stages, maturity stages also, that the different stages of maturation in case of fishes, I am talking majorly of IMCs. Immature stage, then maturing phase, mature phase, then ripening phase, ripe phase, and sometimes a running phase is also identified. And if the fish has entered into the running phase, if you are selecting that for breeding, or in nature if it has to respond, if it has to breed, when the fish has reached to running stage, then as soon as the environmental conditions become conducive, what are those conditions? Cloudy condition, then if there is, if it is raining that day, if there is a flooding condition, all these conditions, the monsoon conditions, in fact, they induce the fish, they provide a kind of cues, environmental cues to the hypothalamus to release GnRH, and that GnRH then stimulates pituitary for the release of gonadotropins. These gonadotropins then act on the gonads to release the gametes. So, as simple as that. So, utilizing this concept for induced breeding of fish, that was happening in the nature. Same thing we can simulate and get the fish breed in confined environments, because Indian measure carps, as I have told you, they usually do not respond, they do not breed in confined waters or static waters like pond. So, as I told you that overprim has provided very good results. I told you that this is from Sindel Laboratories. It increases the rate of fertilization, and it should not be hatchling rate when you are writing, it should be hatching. Increases rate of fertilization and hatching, healthier hatchlings obtained, it has long shelf life and can be given intraperitoneal or intramuscular, whatever suits you. And more importantly, you have to give only one injection. In case of pituitary, we were giving 2 injections. Here, we have to give only 1 injection. And the injection is already prepared. You don't have to go for extracting the pituitary and then preparing the extract. Here, everything is prepared. Just take out the required volume and give it to the fish, inject it to the fish. And so, we get better reproductive performance while using overprim, and quite easy to use. What are the doses of overprim which have been used for induced breeding of fishes? Especially in our country, I'm focusing more on the fishes which are from our country, especially the Indian measure carps. 0.5 ml per kg body weight, general dose, people say, usually for female in case of Indian measure carps. And this dose may vary among finfish species and the physiological state of. I told you earlier in this lecture only that while deciding the doses, here if you see the table, here they have written 0.4 to 0.5 ml per kg body weight for katla, 0.3 to 0.4 ml per kg body weight for rohu, and 0.25 to 0.3 ml per kg body weight for mirgal. Among these 3 Indian measure carps, in fact, katla responds, not very well to inducing agents for induced breeding in confined waters. So, to breed katla is always a kind of challenge among Indian measure carps. This is the toughest one to get induced breed. So, what we do, we have to simulate all the conditions which are required, which can give the desired environmental cues to the fish, and we can also use the overprim doses to little higher side, Again, while deciding the dosage, you will have to see the condition of the fish, the maturity condition, whether it has entered into the ripe stage or not, and again the conditions existing that day, climatic conditions, environmental conditions. For rohu and mirgal, you can use little lower dosage, but for katla, you will have to be very alert and provide. I can tell you one example that fishes, we were doing induced breeding of Indian major carps. Rohu was responding well, mirgal was responding well, but katla was not responding. Katla was not breeding easily. So what we did, we were doing this in breeding hapa. Hapa concept I explained you in my earlier lecture. The enclosure of muslin cloth which is fixed with the help of bamboo poles inside the pond. So what we did, because we are doing it inside the pond, there is no water circulation, and when we were doing that experiment, then on those days there was no rain. So what to do? So what we did, we got one pumping set in order to extract water from the pond and then throw the same water through big shower. What we did, we put a foot valve just to extract water using pumping set. You must have seen there is one foot valve which sucks water and gets it to the pump. We put that foot valve connected to a wide broad pipe. That was foot valve was put into a bamboo basket, and that bamboo basket having the foot valve was kept just under the breeding hapa. That pipe was connected to the pumping set, and then the water which was being sucked from below the breeding hapa, that water was now being expelled through the other side of the pumping set, and to that outlet we connected one pipe, and through that pipe one shower was created, and shower was created with the shower that was made using the iron material, which is usually used in construction industry, like that big iron pot type of thing that is used for collecting the construction materials. We used this thing and we got it perforated at different places, and then this was covered with the other similar kind of material, and this was connected through pipe to the outlet of the pumping set. So water was being sucked from the inside of the hapa, which was fixed through the bamboo poles, and the foot valve was kept here, and water was being sucked from here. It was coming to the pumping set. From here, the water was, being provided to the shower, big shower. So water was traveling from here in this direction, going in this direction, and then coming from the upper side of the hapa. This created a kind of flow in that system, and the fishes could feel that they are getting rain, heavy rain from the upper side, and the water is showing movement. So a kind of flooding environment with heavy rain was simulated. When we did this, there was excellent response of katla with the same doses of the inducing agents. So simulating the conditions, understanding the conditions is again very important. You will have to manipulate all the conditions for getting better results. It's not only that you will just inject in the fishes in whichever state it will respond. No, you will have to take care of all the conditions, all the factors which are influencing induced breeding that you can study. You should try to keep every of the parameter, important factor influencing induced breeding into the optimal range, and then give the inducing agent, any hormonal injection, pituitary gland, or any of the other inducing agents. You will certainly get good results. For most species, overprime a single dose is required, as I told you that in case of Indian major carps, with one single dose, we get very good results. But this single dose is effective in fish that are within or near their natural spawning season. So, we usually, I told you, in case of Indian major carps, we usually use it in the monsoon season, but to get them breed in confined environment. So, they are in the good stage of maturity, and we give single dose and they respond. But there are certain other species for which you may be required to use a split dose. So, when you are using a split dose, then a loading dose, the first dose of 10% of the total dose should be injected, followed by injection of the remaining 90% of the total dose. Total dose you will have to calculate first per kg of body weight, how much dose is needed. Then 10% of that you can use as the first injection, and after about 6 hours you can use the remaining volume as second injection. So, if you are doing this way, then chances become more for the fishes which are not responding so easily. In warm water species, ovulation may occur in as little as 4 hours post treatment. So, fish should be monitored accordingly. Again, I should say this depends on species and the conditions. It's not that you always get response or ovulation after 4 hours, but it depends from species to species and condition to condition. But this thing is sure that males may respond earlier or easily than the females, and that is why you, in the earlier table, you must have seen that we have shown males require little lower dosage of overprime compared to females.